Question 19. The data in the table below shows the yearly salary of a worker T years after starting a job. Okay, so assume a linear relationship between S and T. So remember, y equals mx plus b is the slope-intercept form of a linear equation. But in this case, we're dealing with S and T for salary and number of years. So instead of S, instead of Y, I will use S, which will represent the salary of the worker. M will represent the slope of the line, and we're going to be multiplying the slope by X, in this case actually T, which represents the number of years after the worker started the job. And here we have B, which is usually the y-intercept. In this case, it will be the s-intercept. Okay, so the question is, what was the starting salary of the community worker? And then, what is the value of the year salary increase? So, now conceptually, what does this mean? The starting salary of the community worker, how can we find this? Well, at year 0, when t is 0, we would have the salary equaling, essentially, so we'd have S equaling, or S equals to B, right? Because 0 times M is 0 plus B is B, so S equals B. So our S-intercept in this case will represent the starting salary of the community worker. Just because at time 0, the salary is equal to B. Okay, hopefully that made sense to everyone. We're going to go through with a question. And second part here, what is the value of the yearly salary increase? That is actually going to be represented by the slope, right? Because rise over run. And in this case, we have salary over years. So the salary is going up, thankfully, right, over the years, described by a linear equation. So the increase of the yearly salary will be represented by the slope. So salary over years, rise over run. So now without further ado, let's actually figure them out. And how can we do that? Well, I'm going to use T1 as 3, T2 as 6, 42,400 as S1, 49,300 as S2 for the slope formula, which in this case will take the shape of S2 minus S1 over T2 minus T1. Usually, of course, it's Y2 minus Y1 over X2 minus X1, but we have switched and replaced Y with S, and our X became T. So there we go. Now, okay, so we have S2, which is 49,300, minus S1, which is 42,400, all over T2, which is 6, T1, which is 3. So 49,300 minus 42,400 is 6,900. Draw a line here. 6 minus 3 is 3. 6,900 divided by 3 is 2,300. So that is the yearly increase in the salary, M. So S equals 2,300 T plus B, which is the S-intercept, or in other words, the starting salary of the community worker. How can we find this? Well, let me just plug in 42,400 for S and 3 for T. Because we know that these two are essentially S and T. If we were to draw a line that relates salary and years after the person starting the job, 42,400 would be a point on that line. So we can essentially plug the coordinates in for S and T. So T is 3 and B we don't know. So let's solve for it. 2,300 times 3 is 6,900. Now to solve for B, I can subtract 6,900 from both sides of the equation, and B will be equal to 35,500, because 42,400 minus 6,900 is 35,500. So the starting salary of the community worker, I'm going to call this question A, is $35,500. Part B, what is the value of the yearly salary increase? $2,300. And that's it. There we go.